Hello dear students, so we'll continue with this chapter, that is chemical kinetics. So in this video I'm going to take a numerical based on the rate law equation. In the first order reaction, D to product, that is D means a reactant. It is found that 90% of the original amount of reactant D decomposes in 140 minutes. Find the half-life of the decomposition reaction. So whenever you get a numerical question from this chapter, first read the question very carefully. Try to find out whether the given question involved zero order reaction or first order reaction. If it is a zero order reaction, whether it is the integrated rate equation or the equation for half-life, you have to find out. If it is integrated rate equation and zero order, you use the particular formula. If it is first order reaction, check which formula you need to use. So from the question I can say in the first order reaction, that means the reaction is first order. So we have to use the first order formulas. D to product, so it's D to product. It's given 90% of the original amount of reactant decomposes in 140 minutes. So we know we have this T, when the time is 0, the concentration we took is R0. And when time T is, any time T, the concentration we took is RT. Now when time is 0, since it is given in terms of percentage, the initial concentration of reactant is equal to 100. So at time T equal to 0, we are starting with 100% reactant. Now next it says that 90% of the original amount of reactant D decomposes in 140 minutes. So when time T is 140 minutes, 90% of the reactant decomposes. That means it's converted to product. So the amount of reactant which is left after time T equal to 140 minutes is 10%. So now let us use the equation 2.303 log of R0 by RT is equal to KT. So it's 2.303 multiplied by log of R0 is 100, so we'll write here 100. RT is 10 is equal to K multiplied by 140 minutes. So using this, what you'll do, you'll first find out the rate constant. And using this rate constant in half-life equation for first order, you'll find the half-life time. So 2.303 multiplied by log 10 is equal to K multiplied by 140. So 2.303 multiplied by, we know the log 10 value. Log 10 value is 1 is equal to K multiplied by 140, which implies K is equal to 2.303 multiplied by 140. Now since the unit of time is minute, the unit of rate constant here will be per minute for first order reaction. Next, let us use the half-life equation for first order to find out the half-life time. So it's 0.693 equal to k t half. So from here we can write t half is equal to 0.693 by rate constant k. And the value of the rate constant is 2.303 by 140 per minute. So we'll put the value of rate constant, that is 2.303 by 140, which we can write 0.693 by 2.303 multiplied by 140, 0.301. Unit of half-life here is minute. So 140 multiplied by 0.301 . So the half-life time is 42.140 minutes. So you can take some more questions from the textbook or any sample question paper you practice, because for this chapter the numerical is very, very important. So please practice. If you have any doubts, you can ask me over the phone. Thank you.